Okay, question 14. We are really getting into the tough places, but some of you will know some of these, and that's really cool. If you know any of these, extra points, you never know what that will do. So here, if you read through everything, we want to be able to find the size of the angle ABD, which is that one there. And as soon as I see this, I think of the alternate segment theorem. Okay, that's the word I think of, the alternate segment. I'm going to write that down. Alternate segment theorem. Now let's remember what that means. It means that any angle, this angle here between the chord, this chord here, and the tangent is equal to the angle created by this chord in the other segment, this one here. So those two angles are the same. So what I would say is, I would say that ABD, little hat about that, equals DFB because of the alternate segment theorem. And I need to write that down because there's give a reason. So there's that. So I now got to work out what that angle is there. I also know this angle here. I know that is opposite the 100, and this is a quadrilateral. So I know that DBF, so DBF equals 80 degrees because cyclic quadrilateral means, and I can say DEF plus DBF must equal 180 degrees because of cyclic quadrilateral. So therefore this is 80 degrees. I know that angles in a triangle, so I know angles, or angles wear gel, so angles in a triangle, I'm going to use the word sum, to 180. So therefore 180 minus the 80 minus that 40 equals 60 degrees. And there's my answer. And I've given all my reasons for each stage as well. So that's really handy. Right, question 15. Whoa, how are we doing, everyone? Now, prove algebraically that 0.73333 can be written as that. A very standard question, and if you remember it and you do it enough, then you'll just go into that automatic mode. Here goes. Firstly, I want to draw out a set. You might not understand that language, but you will in time. I want to take out a whole cycle of this. Okay, now I know I'm going to call this is my one cycle, but if I multiply this by 100, I get 73.33 recurring. Okay, if I times it by 10, I get 7.33 recurring. And look, this is magical. I can take one away from the other, and I'm left on this side with 100 take away 10 is 90 lots of n equals, and all these cancel out. So I just left with, in the end, 66. That's so cool. Then I want 1n, because that's what I had there. So I divide by 90 on both sides. And then, if I then divide everything by 6 here, I get my 11 over 15. Again, that's, if you know this one, those marks are yours. Right, let's go over to this question here. It's worth 4 marks. Let's see if I can do this quickly. Estimate the distance a car traveled in the first 30 seconds. So this is a speed time graph, and that reminds us of speed. Distance is speed times time, so it's an area thing. So I'm going to estimate this. So if I draw a triangle like that, that's what I'm going to estimate that. So that's going to be a half base times height. So that's 15 times 9. If I do 15 times 9, I get to 135. Use your calculator, but that's an estimate. Now what's interesting here is I haven't gone straight up, I've missed this bit out here. So where this question says, right, is it an underestimate or an overestimate of the actual distance? Well, I've missed that tiny bit out, so I've missed the space out, so it's an underestimate because my line is below the curve. So I've underestimated it slightly. And it says, Julian uses the graph to answer this question. Work out estimate for the acceleration at 60 seconds. And he's got it wrong. You see, he's done very similar to what I've done, okay? But it's kind of wrong because he's doing acceleration. Now, what you need to understand is acceleration is the gradient. That's what you've got to work out. So it's a gradient of this one. But what he's done is done the average. So he's gone from there to there, and he's worked out what that gradient is as 15 over 60, or 13 over 60. That's the average. He's done the average. So he has done the average acceleration. Or what you can say is, what he should have done was drawn the tangent line across there, a line that just touches it, and worked out that. So you could have said he should have done the tangent at the point that they want, which is 60-12, or 60-13 rather. So you could have said one of those two things, and that would have got your full marks.